Good morning and welcome to session 2. First topic given in modern physics syllabus is Bohr atom model and energy. So we'll start with a bit of physics humor which I had read a long time back, and I suppose you will also enjoy this. This story was shared by Ernest Rutherford, the president of Royal Academy and the Nobel laureate. So he was awarded Nobel Prize for his contribution, that is nuclear based atom model. Story goes like this. There was a question given in an exam and the examiner was a little confused in some of the answers given by a curious boy. The question was, show how it is possible to determine the height of a building with the aid of a barometer. I hope you all remember, barometer is a device used to study the variation in pressure. The concept behind was the atmospheric pressure varies with height. So as you go up in a high-rise building with the barometer, there will be a reduction in the atmospheric pressure, which can be calibrated with the height. When the examiner went through the answer given by the candidates, he came across an amusing answer in one paper. The answer was, take the barometer to the top of the building, attach a long rope to it, lower it to the street, and then bring it up. Measuring the length of the rope is height of the building. The student really had a strong case for full credit, since he has really answered the question completely and correctly. On the other hand, if full credit is given, it shows he is very competent in physics or that part of physics. But the answer did not confirm this. So he called that particular student and gave time for another try. He gave the student 6 minutes to answer the question with warning that the answer should show some knowledge of physics. At the end of 5 minutes, he had not written anything. Teacher asked him whether he wished to give up, but he replied, he was just thinking for the best one. That means he had many answers for the same question. So in the next minute, he dashed off his answer. It was like this, that is, take the barometer to the top of the building and lean over the edge of the roof. Then drop the barometer and note the time for falling. Then use the formula S is equal to half at square, 0.5 at square, where A is the acceleration due to gravity. So height of the building is out. To settle this matter, another professor was called, and he was Sir Ernest Rutherford. And he spoke to the boy and asked, what are the other answers he was thinking for choosing this best one? Then student said, there are many ways of getting the height of a tall building with the aid of a barometer. You could take the barometer out on a sunny day and measure the height of the barometer, the length of its shadow, and the length of the shadow of the building. Then use simple proportion and you can determine height of the building. Okay, fine. So what are the others? Student answered again. There is a very basic measurement method you will like. So in this method, you take the barometer and begin to walk up the stairs. As you climb the stairs, you mark off the length of the barometer along the wall. You then count the number of marks. This will give you the height of the building in barometer units. Interesting, no? Because he has given the answer height of the building not in meters but in barometer units. You just think about that. It's very interesting. Then there is a very direct method he shared. That is, you can tie the barometer to the end of a string, swing it as a pendulum, and determine the value of the acceleration due to gravity at the street level and at the top of the building. From the difference between the two values of acceleration due to gravity, the height of the building in principle can be calculated. On the same track, you could take the barometer to the top of the building, attach a long rope to it, then lower it to just above the street and then swing it as a pendulum. You could again find the height of the building from the period of the precession. He concluded that there are many other ways of solving the problem. Beautiful, no? Fascinating physics. Fantastic. So he suggested, probably the best one is to take the barometer to the basement and knock on the superintendent's door. When he answers, you speak to him as follows: Mr. Superintendent, here is a fine barometer. If you tell me the height of the building, I will give to you this barometer. Wow, a fantastic mixing of thoughts. So at this point, the examiner asked the student if he really did not know the conventional answer to this question. He admitted that he did, but said he was fed up with high school and college instructors trying to teach him how to think. So we should give students an open atmosphere. So we should think, we should go beyond. This is actually talking about go out of the boundary. So then only you will be able to bring good results and good thoughts, and it is that mixing of new thoughts that is an essential requirement for a budding scientist or a good student. Who was this student? Yes, he was Niels Bohr. So today we will be discussing his atom model, that is Bohr atom model and the formula for energy. So here is the photograph of Niels Bohr. His period is 1885 to 1962, and he proposed his popular atom model, that is Bohr atom model, in 1913 and studied the radiation emanating from the atom, for which he was awarded Nobel Prize in Physics. When we go for atom models, generally we start with Thomson model of atom, also called plum pudding model or resin cake model. Sometimes we call it watermelon model. So we stated atom as a sphere of positively charged matter of size around 10 to the power minus 10 meter, and electrons are embedded, that is like plum pudding. But this Thomson's model of atom could not explain atomic spectra and also the result of alpha particle scattering or gold foil experiment. So I request you all to go through those points in depth, because I will share a brief account. There is alpha particle experiment by Rutherford introduced the concept of nucleus. In his scattering experiment, it was found that majority of alpha particles are going straight through the gold foil without appreciable deflection. However, a few, maybe 1 in 8,000, that is what when you study that alpha particles experiment, you come across this type of numbers. 1 in 8,000 or so even experienced a very large deflection, which could not be explained with Thomson model of atom. So Rutherford's experimental mind could give a wonderful explanation, because since alpha particles are positively charged and massive, so hence such a large deflection of alpha particle is possible only if there is a concentration of positive charge within the atom. This introduced the idea of nucleus or nuclear planetary atom model. So according to which electrons are revolving around the nucleus in circular orbit, and the force of attraction between nucleus and negatively charged electron will provide necessary centripetal force for electrons to execute circular motion around the nucleus. But there were two major drawbacks, because a Rutherford atom model was a classical atom model. When electrons revolve around the nucleus, the centripetal force will make electrons an accelerated charge. But classical electromagnetic theory explains that an accelerated electric charge is a source of electromagnetic radiation. That is, electrons in motion will radiate electromagnetic energy. But you know, energy can neither be created nor be destroyed. That is, there is reduction in energy of electron as it circulates. So it will gradually spiral in and finally end up in the nucleus. But it does not happen. So as per this theoretical studies, this is what is expected, but that doesn't happen. There is majority of the atoms are stable. So it became a question. Also, if electrons spiral inwards as expected in Rutherford model, then there will be a continuous emission of radiation from the atom. But it has been found that even the simplest hydrogen atom, while emitting or it emits discrete spectrum, say line spectrum. So we study this hydrogen spectrum as line spectrum, and it's not a continuous spectrum. So at this point, I suggest you to download my PPT number 3 from the collection shared in Love of Science and Humanity. So you can access from my webpage, college website. Link is also given. So please download that PPT number 3. You will be getting a lot of extra points on this atom model. Okay. So this Niels Bohr was a Rutherford student. He analyzed the issues with Rutherford atom model and tried to understand the errors with the Rutherford model. One major issue with Rutherford model was that Rutherford used the then available classical theory to explain the experimental results on alpha particle scattering, which was the reason for the failure of the atom model which he had proposed. However, it was a new beginning in our perspective on material world in a broader sense, or it was leading a transition to a quantum world, a paradigm shift. So according to Bohr atom model, according to Bohr, an atom is having a size of 10 to the power minus 10 meter, and hence it is a quantum system where classical theory is no longer valid, and hence he tried to incorporate quantum modifications in Rutherford atom model. I suppose Bohr atom model is clearly available, very much clear in your mind. You have studied, you have come across that atom model picture. So in order to explain his atom model, Bohr proposed a set of postulates. So without a proper proof, so he postulated these are required based on the observations or experimental understanding of the atom. So he said that these are required to explain atom. So he postulated. So since quantum mechanics was in the beginning stage to account for some of the behaviors observed with atoms, so he put forward these statements as postulate. And there are 4 major points, which are: first one, electrons revolve around the nucleus in circular orbits called stationary orbits. And the electrostatic force between this negatively charged electron and positively charged nucleus is used for providing centripetal force. That is stationary orbit. That is the one concept he introduced. Second point is quantization. Quantization or quantum conditions means some restriction. That is, there are certain restrictions on the permitted orbits. According to Bohr, that is called Bohr quantum condition. That is, permitted orbits are those in which angular momentum is an integral multiple of h by 2 pi. H is Planck's constant. Its value is 6.62 into 10 to the power minus 34 joule second. And n is principal quantum number. And quantum number, that principal quantum number value will be 1, 2, 3, etc. So h by 2 pi, sometimes we call it h cut, h bar, h cross, etc. Then the third point is, when electrons revolve in stationary orbits, atom will not radiate energy. That is, when it is moving in stationary orbit, it will be stationary. Stationary means no variation. So that is why we call it stationary orbits. Okay, non-radiating orbit or stationary orbits. Then the fourth point is, electrons radiate energy when they jump from high energy orbits to low energy orbits. That is, E1 and E2, if E2 is greater than E1, that is E2 is having higher energy, E1 is having lower energy, then the difference in energy will be released as some frequency of quantum. So E2 minus E1 will be released as h nu, or nu, the frequency of radiation emitted is E2 minus E1 by h, and that is called Bohr's frequency condition. So you may note that frequency is the property of a wave and h nu is the property of photon. That is energy of light photon. Or light exhibits dual nature, that is wave and photon nature. So Bohr initially stated all those points as postulates. He then extended his postulates to understand the spectrum of light, that is line spectrum emitted by hydrogen atom. So three core points of the postulates are: first one, centripetal force, then Bohr's quantum condition, and Bohr's frequency condition. These are the three major points in that discussion. So he used these core points to establish his atom model. So using these points, he calculated the radius of the first orbit, or radius of the orbits of hydrogen atom, then energy of electrons in various orbits, and correspondingly he calculated light emission or frequency of light emitted. So from the first equation you can write kinetic energy, that is half mv square is the kinetic energy of electron. So here see on this slide you can see some of the equations. First one is centripetal force. So centripetal force is provided by electrostatic force of attraction. So electrostatic force of attraction is 1 by 4 pi epsilon 0 Ze into E by R square, that is equal to mv square by R. Okay, kinetic energy of electron can be calculated. So then Bohr's quantum condition is angular momentum is an integral multiple of h by 2 pi, that is mvr is equal to nh by 2 pi, and Bohr's frequency condition is nu is equal to E2 minus E1 by h. So from these equations, or if you manipulate these equations, we can collect all the required information, that is what is the radius of these various orbits of hydrogen atom, what is the energy of electron in a particular orbit, and what is the frequency of radiation emitted when electron is jumping from higher orbit to lower orbit. So here kinetic energy is half mv square. So from the previous expression you can get half mv square is equal to 1 by 8 pi epsilon 0 Ze into E by R. And centripetal force is 1 by 4 pi epsilon 0 Ze E by R, that is 1 by 4 pi epsilon 0 Q1 Q2 divided by R square, that is mv square by R. And Bohr's quantum condition is mvr is equal to nh by 2 pi. So if you incorporate the second equation, that is Bohr's quantum condition, you will be able to arrive at the equation for radius of the orbits. So that constant radius, that is electrons revolve around the nucleus in circular orbits. So you have to manipulate these various equations and you will be able to arrive at the radius of nth orbit in Bohr atom model. So from Bohr's quantum condition you can write V square is equal to n square h square divided by 4 pi square m square r square. And kinetic energy mv square by 2 is 1 by 8 pi epsilon 0 Ze E divided by R. So when you club it, that is V square you can substitute, and if you rearrange and solve you will get this radius. You can arrive at the expression for the radius of electron orbit. R is equal to epsilon 0 n square h square by pi z m e square. You have done this in class 12. That's why I'm just giving only the final result, and you can do little rearrangements in this expression and you can arrive at this expression. Okay, so you may do this. That will be a good exercise for you. So from this expression, radius varies as square of n square. That is for hydrogen atom, z is equal to 1, and if you substitute the values and solve, you will get radius of first orbit of hydrogen atom, and that will be 0.53 angstrom. And that first orbit of this hydrogen atom is what we call, or radius of first orbit of hydrogen atom is what we call Bohr radius. Similarly, we can do some manipulations in these equations or those previous equations, and you can get the energy of electron in a particular orbit. So we have already seen that kinetic energy of electrons, that is half mv square is equal to 1 by 8 pi epsilon 0 is Ze E by R. Similarly, electrostatic potential energy is given by the basic equation, that is minus 1 by 4 pi epsilon 0 is Ze E by R. Actually Q1 Q2 by R, that's the form, where nuclear charge and electronic charge and radius R, which is the distance between the point charges, assuming nucleus is also a point charge. So that is the expression for potential energy. It is a central potential and depends only on R. Then negative sign shows that it is attractive potential energy. Then total energy is nothing but it is a sum of potential energy and kinetic energy. Okay, so when you are calculating this total energy, you will be getting again minus 1 by 4 pi epsilon 0 is a d into E divided by R, which is a negative potential, negative energy. Total energy is negative. So what does it mean? This total energy is negative. So negative means it is attractive. So only if that energy is attractive, then these electrons will be held by the nucleus. Otherwise, system will not be stable. So that negative sign indicates the stability. So you can substitute the expression for radius, which we have seen in the previous slide, and that you can substitute here, and then you will be getting a final expression. So on substituting and solving, you will get the expression for total energy of electron in the nth orbit. So here as well, there is an expression n square, that is minus mz square e raised to 4 by 8 epsilon 0 square n square h square. This equation is quite familiar to you all. So total energy is inversely proportional to n square and it will be negative. Okay, so here that expression is given, that is radius r is equal to epsilon 0 n square h square by pi z m e square. When this radius term is supplied or substituted in that expression for total energy, minus 1 by 4 pi epsilon 0 z e by r, then you will be getting the expression for total energy as minus mz square e raised to 4 by 8 epsilon 0 square n square h square. That is, it is inversely proportional to n square and the total energy is negative. So that is, as the value of n increase, negative number En decrease. That is total energy increase. Total energy increases as n increase. Okay, though n is in the denominator, it is a negative data. So outer orbits are having higher energy than inner orbits. So you can calculate the energy of electron in the first orbit, second orbit, etc. And for hydrogen atom, energy of electron, if it is in the ground state, n is equal to 1, it is minus 13.6 eV. And for higher orbits, it will be minus 13.6 by n square, that is 2 square, 4. Then minus 13.6 by 9 eV, like that it will come. So minus 13.6 eV is the first orbit energy. Then energy is inversely proportional to n square. So minus 13.6 by 2 square for the second orbit, electron volt. Then minus 13.6 by 3 square, that is minus 13.6 by 9 electron volt for third orbit, and so on. So when an electron in a higher orbit goes down to lower orbit, this difference in energy will be emitted as photon or light. Or delta E is equal to h nu. So you may note that nu is the frequency of the wave and h nu is the property of photon. That is, light exhibits dual nature, both photon and wave nature. So frequency of the wave emitted will be nu, which is connected to difference in energy upon h. Okay, I stop here. So please revise the topic with the help of PPT number 3, that is atom model given in Love of Science and Humanity. Also, you can go through your class 12 textbook. You have studied all these Bohr atom model perfectly in class 12, so it is just a revision. So that's why I'm just giving you a very brief account of these various points. So with the help of your textbook, class 12 textbook, and notes which you have prepared earlier, so it will be easy for you to make a very nice notes and get a better understanding of Bohr atom model. Okay, so please revise and come. So maybe next class, gradually we will get into other atom models like vector atom model, etc. Okay, thank you. Have a good time. Bye.